Good day to all plenary, keynotes, invited symposium speakers and presenters. My name is Sylviana Sinawat from UiTM and I will be presenting a study entitled An Insight into Cholesterol Reducing and Bile Salt Hydrolase Activity of Lactobacillus species as Potential Probiotic Bacteria. This study is supervised by Dr. Maimuna Mustaqim, a senior lecturer of Center of Medical Laboratory Technology, Faculty of Health Sciences, UiTM Puncak Alam. To begin, cardiovascular disease such as coronary artery disease is one of the major contributors to global mortality and morbidity. The WHO has predicted that by 2030, CVD will remain the leading causes of death, affecting approximately 23.6 million people around the world. The risk of heart attack is 3 times higher in those with hypercholesterolemia. Due to expensive existing pharmacological therapy with many adverse effects, people may avoid the use of said therapy by practicing dietary control and supplementation of probiotics. In the interest of their promising effects on high lipid profiles, probiotics have become increasingly recognized as supplementations for human consumption. However, the exact mechanism of hypocholestemia effect of probiotic remains unclear. The most perceptive mechanism hypothesized is the conjugation of bile by BSH, which resulted in the assimilation of cholesterol. Therefore, the current study was carried out to efficiently isolate Lactobacillus species with high capacity of BSH activity and possess hypocholestemia effect to be used as potential probiotic bacteria. The present study was carried out in collaboration with UNICEF, in which they provided 228 samples of lactic acid bacteria in the form of glycerol stocks. All the samples were cultured using the in vitro culture-based method to phenotypically identify Lactobacillus species via gram-stand, catalase, and oxidase tests. Further identification was carried out by molecular means to further establish the samples as Lactobacillus species and to identify strains that possess BSH enzyme with the amplification of BSH gene. BSH positive samples were then proceeded onto a set of analysis for probiotic properties, included bile and acid tolerance tests, BSH activity assay, and cholesterol assimilation tests. Data then was analyzed using one-way ANOVA by SPSS. From the conducted methods, the present study found 34 samples phenotypically identified as Lactobacillus species, in which the properties as such, gram-positive bacilli with negative reaction for both oxidase and catalase tests. The result was further established by PCR of 34 amplicons of Lactobacillus species with molecular size 231 base pair, which associated with the size of target gene of Lactobacillus species. Amplification of BSH gene at 104 base pair had revealed that only 12 samples possess BSH enzymes. The 12 samples subjected to analysis for probiotic properties. The samples exhibited good capacity for tolerance to 0.3% bile salts after 3 hours. This is important as probiotic agents are expected to pass through the gut and survive the presence of bile salts. The survival and longevity of probiotic agents are further solidified by their ability to tolerate extreme acidic environment of the digestive system. This showed in the present study, whereby all the samples displayed ability to survive under simulated gastric juice conditions at pH 2. In regards to BSH activity, the deconjugation of sodium taurocholate bile salt resulted in production of toxic hydrogen sulfide. Therefore, the present study employed the deconjugation of glycine for suitability of isolates to be used as probiotic agents. Ramasamy and colleague in 2010 reported similar findings to the current study, where the strains showed high capacity for deconjugating sodium glycocholate bile salts. High capacity of BSH activity are often associated with reduced cholesterol level. In the present study, all 12 Lactobacillus isolates have the ability to remove cholesterol from the growth medium after 24-hour incubation. The actual mechanism by which probiotics reduce cholesterol at the molecular level in the host is not yet understood. However, one mechanism of action is convincing due to the fact that cholesterol is the precursor of the de novo synthesis of bile salts. The conjugated bile salts are very soluble, and most of them are reabsorbed by entering the enterohepatic circulation. By contrast, the unconjugated bile salts are insoluble and are less efficiently reabsorbed, therefore excreted in feces. BSH hydrolase conjugated bile acid to liberate free primary bile acids, which increases the de novo synthesis of hepatic bile acid and thus reduces blood cholesterol. From that, the current study is in accordance with several studies that showed correlation between high activity of bile salt deconjugation and reduced cholesterol level. The present study does have limitation, which is not all assays to further establish the isolates as probiotic agents can be carried out due to limited funding. However, several crucial aspects, which are functional, beneficial, and safety aspects of the selection of probiotic agents, did proven in the present study. To conclude, the present study showed that the 12 Lactobacillus strains were able to deconjugate bile salts and remove cholesterol to varying degrees. And on that final note, that concludes my presentation. I sincerely appreciate your attention. Thank you.